I hope that it, no, because it's run out of space. How long you go? I don't know. Okay, guys, focus. Even, because most of us are here, even if those two people can make times in their own time to sing. Okay, redox. Nicola, what is, actually we'll go James. James, what is the definition of a redox reaction? How does it differ from an acid-base reaction? You want to say it? The oxidation numbers change. Yep. Transfer of electrons. From what to what?
Oxidation to reductant. Oxidation is lost to reduction to oxidation.
Okay. If I am a reductant, okay, let's just go through this, guys, very quickly. It's year 11. If I'm a reductant, I am reducing something, well, that's something else. I'm reducing an oxidant. Therefore, am I giving it electrons or am I taking electrons from it? Reducing. Okay. What's the best way to think of it? What's the best way? It would be oxidation numbers. All right. Okay. Shh. Let's go by oxidation numbers. If you are reduced, you decrease in oxidation numbers. You decrease in oxidation numbers. If copper goes from a 2+ to a 0, it is reduced.
Because it gains electrons.
Exactly. So, if I were to balance this half equation, I've balanced for everything. Where do I add the 2 electrons? Okay, you have to always add electrons to the more positive side. Now, it's being reduced because it is gaining electrons. But it is taking electrons from something else. Will that something else go up in oxidation number or down? Up. Up. So it will be, what's it called? What's its job?
It's the oxidant.
It's the oxidant or oxidizing agent. Are we happy with that?
So which way does it go?
So where did the electrons go from?
No, from the reductant.
Excellent. From the reductant. Think about it. Guys, the reductant is reducing the oxidant. It is giving it electrons. The reductant is giving away electrons. The way I always think of it, which I think I told you guys are going to laugh at me. They're just examples.
Is this your murderer thing?
Think about, yes.
Oh,
The murderer. Maybe I'll stop you. It helped me, okay? The murderer murders the victim. Like the reductant reduces the oxidant. It's exactly the same thing. I don't know how it doesn't help you. Yes. If you're a murderer, you're not murdered yourself, are you? You're murdering someone else. That's why the oxidizer, if we have an oxidizer, oxidizing agent, it oxidizes something else. That's its job. But itself is what? Reduced. By? Does it gain or lose electrons? Gains electrons. It's reduced, it gains electrons because it's gaining a negative charge. It's reducing in charge. Are we happy with that? very quick revision. Involve the transfer of electrons from reductant to oxidant. Yes? The species that has gained electrons has been reduced. Happy with that?
Yeah.
The oxidized species has risen in oxidation number and has lost electrons. There's so many different ways you can say this, but don't get it mixed up because you'll get the whole exam wrong. Do you get what I'm saying? If you have it wrong in your head, I remember some of your year 11 tests. Was it you that they were laughing?
No, not really.
No, because, guys, it's pretty much a 50-50 chance of getting it right.
Oh, yeah, I remember after the SAT that
Uh,
I don't fail.
You pretty much, exactly, because if you get it wrong from the start, you don't get consequential marks. Otherwise, they're just, you know, because it's either one or the other. Are we not, how are we not going to fit? I think the murderer,
Yeah, which one's the murderer?
no, but it doesn't matter because the murderer is not murdered. Yeah?
He is still which one again?
No, oxidation. Guys, just remember, oxidation, the process is, oxidation is loss of electrons. Reduction is gain. Oil rig. Okay. The reduced species has lowered in... Guys, stop talking. Give me a little bit more time and then we're done. The reduced species has lowered in oxidation number and has gained electrons. Are we happy with that?
Yes.
None of these sentences can be opposite in your head. We have to rectify that. Okay, oxidation and reduction occur simultaneously. Why do I say that?
Because it's an oxidant needs reduction.
Excellent. When someone's gaining electrons, it has to be getting it from somewhere. When someone's giving away electrons,